go ahead and get started with let's continue the discussion a little bit on. I don't want to spend more time on the error that I generated on the sheet format. I did download SolidWorks 2018, so the one thing that you're going to see a little difference is the opening screen, and the other thing is that I will probably end up putting the do not show on startup. Just because of my workflow, the way I prefer. This will be a novelty for a little while, but then I will probably do away with it as far as something that I want to see every time 2018 comes up. So the issue that we had with the pages, or I'm sorry, the additional sheets, reading the first sheet information, not producing new sheets for the next page. This is the template that I created last spring. All right, and I went through kind of the same convoluted process of make sure that you have your options, get your background information, parameters, all of those settings the way that you want them. Even when I installed 2018, I would say probably, let's take a quick look. I would say probably and the big issue is the file locations. 2017. What was my custom property file should have come over, so it found my previous settings. When you do a fresh install, it's going to go all 2018 stuff, or you did the fresh install for the education version of 2017, it's all fresh install. The issue that I want to make you aware of is in corporate and industry, you're going to run into these piggyback installs. And if they've done it over multiple years, because even on a 3 to 5 year lifespan of the computer cycling in and out, you're going to see 2 or 3, 4 versions of software. The symbol library. That was one of the ones I was looking for that I don't think was in 2017. All right, so it's still pointed back to the 2017 location, even though I'm in 2018. So it says all of that stuff was working. It must be great. We're going to point to it. Well, the issue is I don't really get an option to say don't point to it. Point to my 2018 folders and make it work. All right, so in corporate, that was kind of the issue that I was trying to correct with my 2017. I had things pointed back to 2014, 2015. However it went along in the cycle. All right, so being aware of those file locations, what's going on in the background in the settings, that's kind of a big deal. All right, so this was the one I created last spring. We'll run through the process real quick, but I want to get back into the drawings so that we can finish up chapter 3 and get into assemblies. So if I go into this one just as the example of what was supposed to happen, I'm going to browse back to the 322, and we'll just bring in the first sheet. Notice that the drawing name, the part name, the description, those all came in and updated. I go to add the next sheet. And sheet format can't be located for 2018. So that's either not been updated or it hasn't located it. But I know where it's at, so just for this one, I'm going to go back to my dropbacks, get to my cloud drive, get into the templates, and that was the A landscape, I hope. All right, it adds the list here, and we go ahead and hit OK. Finds the sheet. That one's doing it too. Let's bring in the next one and make sure. All right, because it's keeping that information, and I want to say that this was working, but now I don't know. And if I rebuild, I don't get it. If I control Q, I don't get it. So that's telling me that I need to go back further in my templates and see what's going on. All right, so I would expect this to go from 322 to 31, which is what I inserted, even if it doesn't have all of the material files, drawn by information. I would at least expect this to update. So if I were to save this 322 and 31 as my drawing files, let's do another test page. Easy to identify, easier to delete. The drawing number updated like it was supposed to, but 31 still has P3-22's information. If I hit Control Q again and go to Control B for the standard rebuild, I'm not getting that update. So I will be paying attention to my the templates that I built in 2014, 2015, see if this is still the case. All right, so model found here, drawing view specified in sheet properties, but notice that the selection is going back to that first item that I inserted. So that's kind of my issue right now. So if tech support doesn't give me the answer I want, I'm going to tell them, go watch the first part of this video. All right, so until I get a resolution on that, stay with the default templates. If we have to, we'll do single part per drawing, but that is not the most efficient way. All right, so we will come back to that though. All right. 324. We're in millimeters. Oh, I jumped out of that just a little too quick. One more thing about the drawing is that our units work the same way as they do in the part in the assembly. So most of these parts that we built have been in metric. So I go into the smart dimensions. Let's see, does this have? No, it doesn't have my layer set up for dims and center. So 2.36 by 2.36 tells me that's 40 millimeters by 40 millimeters. I recognize that number, but it does not give me the desired result. Oh, 60 millimeters. How did that happen? Can't do math, apparently. That's right. 6 millimeters is 0.236. All right. So I want it to go over to metric. We're going to come down to the units just like we would in the other part. Switch from inch, pounds, seconds over to millimeters, grams, and seconds. And that puts our drawing into metric. Then individually, if I want one of these to be dual dimension, I can come over, select for it. Or that we can go back in, and since millimeters are now my primary units, when I edit the document units, let's see, where is it hiding? Dimensions? No, I didn't need those. I will point out the add parentheses by default. If that's checked, everything that you insert gets a parenthesis, which is usually a reference dimension, not a real dimension. So if you're getting parentheses, come in and find the dimensions and uncheck the add parentheses by default. Dual dimensions then. I want dual dimensions. Let's go ahead and put my dual dimensions on bottom. And that is going to reference then the units that says my top units are millimeters. Well, they were inches until I changed it. And millimeters in 2 decimal places. And then my secondary units will be inches in 3 decimal places. And let me get out of that. And then now I'm going to get the bracketed number that tells me top is millimeters, bottom is in inches. Or I can put them off to the right side, to the left side, however you want to organize it. And then keep in mind too that this is the ISO drafting standard. And like I said, I started using it and decided it had some advantages. But if you prefer ANSI, switch it over to ANSI. Oh, and did it get kicked out my? That's interesting. I didn't know I'd do that. Dual dimensions on bottom. All right. So you can manipulate it. You can go through and you can pick individual items to update, change, or you can go through and say globally, I want it for this document. Just making those option changes at this document level, I do not believe it saves it to the next drawing. So if I save this back to my drawing, go back in and say new, and we had my landscape. It switched back to inches, pounds, edit document units, takes me back, and inches, millimeters. No decimals on the millimeters. That's nice. And then the top is dual dimension is turned off. If I wanted to always dual dimension, I would have to set that, and I believe save it to either the sheet format or the drawing template. That's one that I'm still not real clear on where exactly those get retained. So one of the reasons that I go File, Save Sheet Format is it updates. And then when you save sheet, or sorry, go into Save As Drawing Template, and it may not be necessary because you can reload, rebuild. It kind of saves that separate step of updating. That brings up another good point, that if you make a change, I make a change and I save this back to the sheet format. I save this back to the drawing template. All of my legacy data has to go through. I would have to go sheet by sheet, and that's right. We'll go down here, customize the menu. Yes, I want to see my properties. I would have to go sheet by sheet in the properties and find the new landscape, even though it's the same name, I would have to find the new version and tell it to reload it to get the latest, greatest information. So we try to build as much of that that data, make sure it's good, solid data into the template and sheet format, and then only the items as they're coming up for revision or going forward are we going to go back through that process of reloading all of those sheet formats to make sure that they're current. So it can create quite a quagmire of get it sinking in the quicksand of let's try and make sure that our sheet formats are good and not make changes on the fly too often. All right, now we'll jump over to drawings. So I guess the takeaway, the expectation for the assignment 4 is going to be that grab one of the drawing templates, whatever A, B, C. If you want to do the ISO versions, that's fine. Pick a working template, tinker around with it, but at this point, say I haven't had issues in the past, I'm having issues now, so when we can get those corrected, then we'll pick up and build our own templates again. So putting 328 through 340 into the drawing, we're going to use one that's either existing or is already one of the standard ones. All right, so 324 has this interesting rib in the back that I keep trying to overlook every time I see it. Other than that, the geometry is pretty well straightforward. Get it up on my second screen here so that I can jump back and forth. All right, so again, this is 2018. We're on the lookout to see what's new and different. I'm going to stay with my part fractional. I guess the one that I'm not quite sure what to do with is that MBD tab, because it puts it in small or very small, small, and then large and larger connotation for the part formats, and then a couple of assembly formats. So I'm looking forward to figuring that out. But model-based definition is right now is one of those things that is a pay-for add-on, and I've seen it in the education version, so we will check it out. But the reason we're looking at 2018 is this is my commercial version. All right, so I turned on sketching because it's kind of cool. We'll take a look at that. But overall, from one version to the next, you can expect to see the same format, the same things. In 2004, when they made the big change to that intermediate format, why did you break everything? What are all the bugs? 2007 to 2008, when they went to this format, why did you make all the changes? Why, so there's always this kind of public outcry of, why are you messing with something that I'm used to? Well, on the other side of it is this is a nicer looking format, and I think 2008 I had the experience or the maturity with the software to say, in 6 months we'll be used to it and wonder why we even had this conversation. So it's not going to make drastic leaps and bounds in the user interface unless there is some really good reason. All right, so front plane, same thing. Colors changed a little bit from the first go around. And missed. Horizontal. and our overall is 100. So I'm going to chop back that little, and since we're in inches, because I wasn't paying attention again, we'll go to 100 millimeters. And because it auto scaled, that is about what I expect to get. All right, so the end is 35 millimeters. And I really better change that over to back over from custom to millimeters, grams, and seconds, so I can enter those values. All right, so we got kind of big there. Scale that. All right, so again, if you catch it early enough, it's not really that big of a deal. Let's see, we have 65 on the end. And then what did we have for length? Lower leg is 60. Oh, there we go, 35 on the edge. All right, and then I would like for that to be mid-plane. Let's see, there were 20, circle of 15, 25 back to that edge. Okay, maybe it doesn't matter if it's mid-plane. I'm going to say it'd be nice if it came up on center, but it doesn't look like it's going to quite work out that way. At least the rib, 30 and 10. Nope, that didn't come out mid-plane either. That would have been 70, so the back, that's interesting. Why wouldn't they make those 32 and a half? All right, so got to figure out how I'm going to shift that then. All right, so this may be one of those places instead of mid-plane. I really, really want that front plane to go through the part about where the rib is going to be. And it's not that it matters so much that I could create a reference plane and generate the same geometry, but if I can get it there in the first shot, it would be a little bit easier. So 35 on the front, direction 2 then takes it out the other 40. All right, and when I do things like that, I'm always concerned about my math. So I'm going to pick the edge, make sure down here at the bottom it says length of 75 millimeters. All right, on this end face, we'll go ahead with the line. And we have 25 millimeters from the outside. And from the edge, let's see, really don't have an angle. So that being the case, we do have a height for the center of the circle and a location for the center of the circle. So we'll see if that edge goes through that midpoint. Oh, there it is, 10. Making it more complicated than it needed to be. Just had to find it. All right, so radius of 15 becomes a diameter of 30. And from that point over is 20. And that would mean that the point is not on that line unless we get a reference dimension that says that's 30. So 32 or 32 and a half, no. All right, so to fix that, I'm going to go in and take it off coincident, highlight the little box, that deletes the relation. And then instead of getting rid of the dimension, I'm just going to come over to its other and uncheck the driven. The driven takes over the dimensioning, and then we can go back to 30. All right, so slightly offset, 20, 30, 65 on the total, 25 back, features, extrude cut. And what I want to see is, will it let me pick the region without generating all of that other geometry? All right, so finding the hard edges, finding the sketch geometry, that region will it will find the hard edges of the part. And then we did all that math to come up with 40, or I can offset from surface and the surface we're offsetting is that side, and it's going to be 60 millimeters to that face. Okay, so if you did this some other way, if you've already been through this project, keep in mind that these are introducing the things that you don't normally use. It's when you're sitting there kind of pulling your hair out, how do I get this thing to work, that I want you to jump into those other end conditions and say, based on the math or the way I see this geometry, I'm going to try offset from surface or up to surface, as opposed to just trying to sit there and crunch numbers and come up with math. All right, so the reason that I went through all of that with the first piece of geometry is the rib should go from there to there on the front plane. And if I did the math correctly, we can accept that sketch. It's still highlighted sketch 3. And over on our command manager, we have rib. It is 10 millimeters wide. I did tell it 35. Okay, so now I'm confused on the math again. But it's showing me a rib. It's showing me the direction that it's going to go. It is set to mid, or both sides. And then we'll just have to verify the geometry. All right, so I don't have to sketch anything additional other than that rib and make sure it connects. Problem with ribs is when they encounter cylinders. So I'm probably biting off more than I can chew on this one, but it is a good worth noting. Let's see. So number 30 millimeters along that edge. So that original math worked out and put me on center. So let's go ahead and place a rib between the cylinder and this outside edge. Now that's a little more complicated than I want. Let's go back to the same plane. So front plane doesn't quite bisect it, so that's okay. I'm going to turn on temporary axes so that I have that to work from. Front plane going to my temporary axis. I should have just drug that off, but I showed you a while back, last couple of videos, that if you highlight the plane, hold down the control button and drag, you will get a reference plane. Now in this case I want it to be parallel, and the second reference becomes that center line. All right, so it picks this plane up and it creates a plane feature or a reference plane off of the side. What I was starting to do with the pre-select was under reference geometry plane, that will take you into where all of your references, your first, second, and third reference are blank. So in the case of maybe I wanted a plane through 3 points, it can be point number 1, point number 2, and point number 3. And now I have a compound angle splitting that part. All right. So don't really need that one. It was just combinations. So the older style of parallel plane at a point, those made more sense. The words made more sense than going through and finding your first, second, and third reference points. So I'll see if I can find that scanned picture of when it was the verbiage of what those planes were describing. All right, so back to setting up the rib. We'll open up the sketch. And watch out for, on the cylinder, that if you go directly to that point, you're having curvature fall away from the rib, and it's either going to generate 0 thickness or it's not going to be able to calculate. So I'm going to go to the endpoint first to illustrate. Prismatic shape, this rectangular shape, not a problem. It's not even going to think about it. Well, let's see, which way did I tell it to go? So it's on that face, so we'll go there and make it a coincident. No. Actually, I'm not sure what I grabbed. Okay, I'm going to go with Pierce, even though coincident should have worked. All right, going back over to the features, rib. It shows the 10 millimeters. 10 millimeters will fit. I'm going to drop it down to 6, though. And failed to create rib feature. Well, that gives you a lot of information as to why it failed. All right. Why it failed is that as this surface is falling away, it can't calculate that linear edge, top linear edge of the rib. So let me get back normal too. And so the solution is to give it, let's see if we can find that silhouette edge. And so a couple new terms, the silhouette edge is where that plane passes through the cylinder. You'll have two solutions. So let me go ahead and apply this one, and then we'll go look for the other one. So coincident puts it on that edge. And so where the plane passes through a cylinder or any curved surface, you will have a line. And we'll have a line on the bottom. That one's a little more prominent. Well, okay, it didn't come all the way around, so I didn't quite get what I was expecting on that one. But that little cylinder with, let's see if it'll come up again, right there. A little cylinder with a line through it, that is a silhouette edge. So if you ever hear that term, I can generate that geometry, I can convert that geometry, and find it. All right, so long way around to get to why the rib failed. But if I were to put as little as, well, let's go 10 thousandths. And we're in millimeters. So let's go, here I go doing math on top of my head again. 0.25. All right, so that gives me defined. And then we'll go back in, pick up the rib. I still want that to be 6 millimeters. Let's go ahead and accept it. Still failed. Okay, that wasn't enough. So it's kind of a tight curvature. Let's see where it will pass at. Ooh, not passing at all. All right, so now I have another question for tech support, because this would have worked in pass. So I'm telling it to do something. Oh, nope, don't have a question for tech support. All I got to do is look at the screen, reverse the direction, see if that one will go. Ah, so close. All right, direction's right. Rib's going the right direction. Everything's facing that way, and we have enough to intersect. Well, I'm just striking out all over the place. Well, making
to make it merge with that curved surface.
Yes.
Bed down.
Yes.
Not like on the curve.
No, and the problem is that it's trying to make this a linear edge, but as the cylinder, the curvature of the cylinder is falling away, I've always been able to move that in a little bit and have it solve. So I still have a question for tech support. So since I bit off more than I can chew on that one, I'm going to call that one good for now, move on to the next one. All right, so I'll have to go back into 2017 and see if that was an issue in 2017, because we have several parts that have those ribs intersecting the cylinder, and I've always pulled it away from the edge just a little bit, and it's been able to solve. And 324. All right, so when we're done with the planes, we will hide those. Oh, and then what I was going to do with plane 2, if that worked. Oh, nope, we didn't want to sketch on the compound. Sometimes the plane is handy for using it as a cutting tool. So if we insert a cut and cut with surface, plane 2, I can chop the compound with that surface or with that plane. I can also generate a surface if it had curvy or wavy whatever's to it. Now, dimensioning that, I'm not bringing this into the drawing luckily, so dimensioning all that just isn't too bad. But planes are valid to cut with. And there are times, well, the sectioning views in the drawings have gotten enough better that probably don't need to section too much with a plane, but sometimes surfaces are handy. All right, so 325 is kind of an I-beam shape, and it is in inches. Come over and take a look. All right, so we have symmetry about all 4 quadrants. Question is, does the notch go through on the bottom? I would say let's assume it does, put it in there, and we can always convert it out later. All right, I'd rather, since everything else is symmetrical, I'm going to make the assumption that that's symmetrical as well. All right, depending on what it does, as long as this isn't rotating at 10,000 RPM, that notch being there or doesn't doesn't affect anything. If it rotates at 10,000 RPM and that notch isn't there, it's not going to be balanced. All right, so I'm going to work towards that symmetry on all sides to maintain a balance that I'm not sure about. All right, so symmetry says center lines, horizontal or vertical. Start with. Put those in place. All right, and then one side will get line, line, and arc. Since it's a partial arc, well, we could go with the, it's 1.75 in diameter. Now that's not fun. Let's go with the 3-point arc, and we'll draw a partial. All right, since I can see its center point, and they gave it, we'll go to coincidence. All right, so 0.5 on the height, and then that should auto scale the drawing. 1.75 on the diameter, but we are in radial. I want that diameter dimension, so I'm going to switch liters over to diameter. And then I can go 1.75 without having to do the math, get it to 0.875, and then 0.25 off of the edge. All right. We're going to mirror in one direction first, so I'm going to window pick, control select the center line I want to mirror across, and then we can window pick, control select the line to mirror across, or the center line to mirror across, and that gives me my geometry. And it didn't put the points at the top of the arc, it just made it a complete arc, but it did put the points at the line, showing me that that was the mirror, that was where the symmetry was at. Because of that notch in the middle, I am going to go mid-plane. And the mid-plane is 3 inches. That doesn't quite look like 3 inches, but I'm thinking that it is. So, yeah, it doesn't look exactly like theirs, but we'll call that good. Coincident to the top edge. Let's go mid-plane. On this one, I'll select, there's my silhouette edge, and we'll go to the midpoint. We can mirror that, but I wanted to show one other one as well. So right-clicking, select midpoint. We can also go back to the origin and make that vertical. And then we still have to find the coincidence to the edge. All right, test for symmetry is to drag, and as one moves, everything else moves. And then let's just go collinear with the sides. And our width is, well, I got the 0.19 deep, 0.75 wide. And we'll have to double check our number. All right, and then I can establish symmetry again by telling it that those are equal. So probably would have gone with the center line and just mirrored it about as easy. But occasionally you will start sketching and realize, oh, now I could have made it symmetrical, but I've already got geometry. Why would I delete it? I'll just go through and add a couple relations and make it work. All right, so if we find out later on that the lower one isn't needed, that it is only the notch on the top, window pick, switch to construction. Still there if I need it. Some future date, somebody comes back and says, hey, you know, that notch that we didn't need, yeah, now we need it. All right, instead of having to go back in and draw it in there, I left it. Everything was related to this one, so if there were any revisions to the size or the depth, it would update to the other one as well. And we decide we don't need it, or we do need it. We turn that back on. The features go through extrude cut and through all both directions. Sets the notch. So still can't see it. When we go into the wireframe, then I'll be able to pick it up. All right. So on the plus side, let's see, we'll get set up for 326 here, also in metric. On the plus side is when you're going through this process as the designer, you're visualizing what this is going to do, what it's going to be, where it's going to be in the assembly, what its function is. You know what most all of these parts are doing. Where we have to make these decisions is I get a drawing from a vendor, and maybe it's a PDF, and I want to get as much of the geometry, but I don't need all of the geometry. I just need the envelope. I don't care about internals. And if it's not a rotating mass, I'm not really concerned about balance. Just I need it to fit into my assembly somewhere. I'm still kind of guessing at what their design intent is. I know what mine is, and I'm relying on their geometry coming in. And until I have the part in my hand and I'm looking at it and saying, yeah, that matches the drawing, I'm not really comfortable. All right, cylinder, and we want it to look like the isometric. I guess it would help to jump over here real quick. There we go. Looking at this cylinder on the right plane, mid plane out, and we just make the notches. This is all symmetry, symmetry, and symmetry, except and even the holes down through the middle. So right plane, sketch. So a big portion of the design, and again, on the when you're sitting down to design and have a little bit, there are still a lot of unknowns. Here we're given the information and we're trying to make sense of it. So you're breaking it down into manageable bits, getting it, getting the geometry on the screen into the system. With design intent, we have a lot of what-if scenarios that may or may not play out. And so getting really attached to your design and this is going to work, this has to work, those are not words that I like to hear in design review conversations. It's we got to let this go and get something that's going to be functional. All right, so that one's good. Oh, I was going to set symmetry on those. So in this case, we'll just look for the midpoint. And let's see, we can go those two and go symmetry. All right, as long as I have the center line selected. Let's see, select midpoint, coincident. All right, get some dimensions on this. We were 10 on the end. Depth-wise, 15 in 4 places and 10 in the middle. And then the width is 20. And that looks strange based on the isometric, but I guess so. So go in here. All right, so checking out why my symmetry or why it's still in blue did not get related. And actually I related everything coincident on this side, so we'll try to make, doesn't like the cylinder. We'll grab the point, look for that silhouette edge, coincident, features, extrude cut. And then even though we're looking end on, through all both. All right, if I just do through all, I'm going to have half of a cut. And then I'll have to go back in and tell it through all both anyway. Oh, didn't want the sketch, I wanted a new sketch. And that can be right at the center of the part. And got a little click happy, so that being the case, I picked up coincident to the edge, which not going to work. So highlight the box, delete on the keyboard. And that dimension is 10. Now 17 from the edge. Ouch. I don't know that dimension anywhere makes me. I don't think that should make anyone warm and fuzzy. If it is actually 17 from that edge, that's a terrible datum to pull that number from. So we're going to check that one real quick. Diameter of 10. And we're still in the smart dimension, so let's see if it 17.32. Yeah, it's kind of got a rounding error to it, but if you want that on center line, I'm not buying that edge. I don't know why that would be off. In 0.32 millimeters, that's what, 20, 25. It's a lot. It's 20. It's almost 32nd of an inch. All right, so we're gonna have some issues with that one. So that would be another one of those. Hey, it was in the drawing. My design intent, my best practices says that ought to be on center so that I can make it in any orientation. Why do I need left and right part? If it needs to be a left and right part and I can get away with a slot, why didn't I make it a slot? Go through that thought process of what are the contingencies so that on the manufacturing side, I don't have to have special setups. I can indicate off of this edge, run those positions, whatever little fixture comes back on center, and we're okay. So this comes back to one of those, yes, I would like that to have an ob round or something around it that says, let's check that out. And then because I did my uncheck of the mark for drawing, that will be one of the items that gets marked for the drawing. So when I insert this, and if we insert model items and bring in dimensions, that one's going to pop up bigger than anything else. Through all, save. And 26. We're almost to the back to the assignment where we're going to have fun with some drawings again. All right, 27. Oh, this is the one that we had the issue with the length. All right, so might as well start with the cylinder again and just come up with a number that that looks good, and then we'll build out from there. So diameter 52. I'm putting these in the same orientation so that they have reference to the drawing, but if you started this drawing on the front and it was facing forward or backwards, it really doesn't matter. If I take it into the assembly and I can orient the part, go through its process, and the test for validity is, does the geometry match? And I still hit inches, didn't I? Yep, 52 millimeters. So, let's not go with dates. Get back in. Okay, so that one stayed. Okay, then I really didn't need to get back into it. Extrude. Well, I'm going to go with the mid plane. And let's see, we have 22. If that's 22 and that's about 20, and that's so we're going to be somewhere around 60, 75. 75 sounds good. Right, until I see where this ends up in the assembly and what it's doing. There's going to be those issues, those questions to make it work. All right, so we're going to have some symmetry here with the notch cutouts. Now, manufacturing this, I kind of look at it as if I'm holding onto this bar and put it in a rotary, I'm still not going to be able to get to the angle. But if I have it in an indexing collet, I could flip it 90 degrees, run the ends off, and still maybe pick up without re-indicating for this this back face. All right, so I'm going in vertically here. So I want to make sure if I can. Well, there's assumption that's on center line, and this one's going all the way through. So let's go ahead and mirror. And we had 20 in the center and 22 deep. And those get extrude cut. And we'll watch for, so through all, one direction, we flip the direction, we're still only getting half. So that's why we're going to go through all both. Starting on the front plane, again, anytime we're interior to the part, making this geometry, we're going to probably end up with both. So 8 below center line. Well, let's go ahead and make a nice center line so that it is apparent what's going on. Below center line with an angle of 30 degrees. And 75 was not a good guess. Extrude cut, through all both. And we're only getting our choices for blind, through all, and through all both because this is an open profile. Right? I only did the one line geometry. I didn't close this off. So if I needed one of those other end conditions, I'm going to have to draw the other two lines, close off this triangle. So through all both will get it there. And the side to cut is up, so it's going the correct direction. That gives me that geometry. Alright, so 12, it looks like maybe this is a little bit longer. So it looks like we're up to 100 millimeters. Update it, nothing changes until I hit rebuild. Makes it a little bit longer. All of my geometry moved with the expansion for midplane, so that's okay. Front plane again. We'll draw the rectangle. Let's see, lengthwise, well, if I make that 12, 24, no, it's a little bit wider than that. Yeah, it still doesn't look too bad. And then, since it's not called out otherwise, my guess is it's going to be on center line. So coincident line to the origin, features, extrude cut, through all. So the difference between the angle and this one was that I closed off the box. Rectangle tool was easier. I could have generated just the two lines and it would have been an open profile and had the same end conditions. So it's kind of whatever you see, how you see it, when you see it. Okay, and then that is diameter 12. And position of 12. And since it is going to be on center line, we're going to grab the center point and the origin, make those horizontal, extrude cut, through all. Doesn't look exactly like theirs, but pretty close. I think this part is a little bit wider, so 110 millimeters. Yeah, not going to chase it that far. All right, so 327, 328. We're back in the back into the polygons, and then the 50 millimeters, I had a couple of students say, well, if that's lying on that face, how do I get it to go straight through? Well, first of all, that's definitely not a best manufacturing practice because the bottom is going to be elliptical. And then that shape becomes really weird. We'll do it that way so you have the explanation, but we just probably quadrupled the cost of that nut because that resulting geometry is going to have some issues. So we'll try it. It'll be an experiment. Not that I haven't painted myself into enough corners. And this is metric. All right, so I do know that the geometry here. Let's go top plane, and we'll pick up the polygon, flat along the edge, so 6-sided. I'll just go ahead and make one side vertical. Let's see, regular hexagon 80 across the corners. All right, so in that case, let's go back to that note. Regular hexagon 80 across the corners. So an inscribed circle touches all of the flats. They're showing 80 millimeters to the points. That's a circumscribed circle. So if I want to use that to my my advantage, let's back up. We'll get rid of that and just undo it. And before I apply it, I'm going to go to circumscribed, so to the outside. We'll get that almost vertical. And set it to vertical. And then if I want to use that that base circle, I can go right to its geometry. All right, so each of the points is touching the circle as opposed to each of the flats being tangent to the circle. Minor differences, but there you go. What did we have for that that slot? We're given 6 12 millimeters wide, 4 places, and since it's also showing on that angle and has the angle, yeah, we'll go ahead and include it. So that being the case, there's the circle, our 50 millimeters. Oh, nope. Got ahead of myself. Let's actually extrude this and make the cut first. All right, so I got to generate that angle to make that work. 35 millimeters. We're going to be back into the front plane, making sure it bisects along the flat. We'll open up the sketch. Angled from, and the distance is 15 millimeters up. Extrude cut, direction of cut's okay, through all both. And then now we have an angle that we can sketch on. It goes normal too. And that's still pretty strange, but let's see, does it look centered on that face? Sure, why not? You know, my tendency would be to go right to the origin, but I'm not sure that the origin is where I want to pick up at. So the center of that face, if we're going to go that far with the geometry, then I'm going to try and get it on center of the face that we're dealing with. Millimeters. Let's go with the center rectangle. We're going to have a lot of construction lines, I can tell. $12 millimeters wide. What did we have for distance on those? 30 on the center. Oh, 30 half. All right, so 60 on the width. And then we'll go with another rectangle. And for that one, we'll just use our equals. All right, so now the fun part. We're going to extrude cut and see if we can pick up all of those either contours. Well, it's not really letting me have, there it goes. If I can grab the 3 contours, that's going to be my best option to get all of that out. All right, so that's going back at an angle. The guess is that these lines really look vertical to me. All right, so that's going to be a direction of cut. So through all, the one that we always jump over, the little arrow, direction of extrusion, is still going to be one of my vertical edges. And that's going to shift it from going perpendicular to that plane to following the vertical edge of the polygon. So it looks like it, and I don't have to like it, but there it is. All right, so arc length. When you see arc lengths as opposed to radiuses, that's telling me that that is elliptical in shape. All right, so just a little bit foreshortened. And the issue here is that I can't just put a drill bit and you know, possibly well, let's see, at 50 millimeters, we probably have the fitting to broach those. You know, run them through the arbor press and just knock those out. Since we're, you know, with the notches, we're probably going to have to wire EDM it anyway. Wire EDM it. Interesting piece. And it would be another one of those. I would really question the that shape, whatever that's going on, whatever it locates for, is just not very mechanically practical. Yeah, I don't. It's a fun shape to make, but it's not something that I would want to design and then give to one of my machinists to make. All right, how are we doing? 328, 329. All right, so more notches, more cuts. Oh, and let's see, 328 was also the first one that we needed to put into a drawing. So let's use the A-size landscape, and we're going to see if this will cooperate with me since I'm not having much luck elsewhere. So bringing the parts into the drawings, let's go with the view palette first. So I think going forward, a lot of companies have adopted this as opposed to the bringing in model views. So 328 was the start, and again, you can bring in as many of the drawing views that you want. And since this has that nice angle for us, we will pick, oh, I still didn't pick. All right, that brings up a good point, is that we're looking end on of that. So let's see what happens if I want to rotate that view to get this a little more aligned with what I need. All right, so if I go to rotate, this little rotate button, that view is selected. That is the parent view. And I'm going to tell it to rotate at 90 degrees. Yes, so you will lose all the dimensions. If you have fully detailed this, you probably don't want to rotate. If you rotate, you want to rotate first, not last. All right, so going that way, then you can kind of see the foreshortening of the circle. And we can now also use, on the view layout, an auxiliary view. So I want to see that view in that direction. So that's a little strange, but it gets it there. And since it's aligned to A, and I really need to put that in some other place other than along that axis, I'm going to right click, and there is this little thing for alignment that says break alignment, so that I can float that out some other place. Don't like the scaling, so we're back into the properties. I want to globally scale this at 1/2. Okay, that's a little less obnoxious, but still not great. We're getting there. All right, so the A view direction is going to stay with its view, and then the view A that's generated has its label, and those are both automatic. All right, so this would be probably a good one to go ahead and set with the hidden lines, so that you see that those are vertical. And that one, I don't know. That kind of confuses it, so I'm going to do hidden lines remove so that you get that sense of the direction. And then we'll try a projected view to the isometric. I think that probably just made it a little more confusing as well. All right, so dimension-wise, what we'd be interested in, and I did not set, oh, we haven't been in this one to set, so let's go new. I'm going to set a dim layer, and it's going to be blue. And again, this would be something that I'd want to set back in the template and save it with, so that I don't have to do this every time. Center, and like the brightness of the magenta. Oops, nope. Escape. And we're going to go to center marks. Let's go for all holes. Didn't find any, which is not surprising. All right, not getting much of anything. In this direction, let's see, even normal too. I would have thought that one would have come up, but given the weirdness of the shape, I'm still not surprised. All right, so with the weird angles, the selection there. Let's see, that one's going that way. It might be part of it's the rotation too. All right, so I'd have to work through that one to actually get to a dimension that we like. Would probably not. Well, let's see if it'll apply. True 0.98. All right, so we're back into that millimeters, grams, and seconds. And because it's off at a off angle, true position is in relation to that angle, as opposed to a normal plane. Oh, and I'm still in my my center layer, so let's come over. Oh, other. Switch it back over to dims. Did not give me a center, so we'll switch the default to dim. Maybe. It's right there where my timer is for the video. Okay, we got it. Alright, so since I didn't get any center marks, we'll leave that. We'll go from the points. Okay, pick a little more careful. Still didn't get it. Alright, so there's my 80. And then to do the modification, and I think I'm probably more prone to just jumping over and saying 2 times. And we'll do the smart dimension again. But if you, oh yeah, it's at an angle, so interesting. And then coming in here, we would have 4 times. So if you get in the habit, it will save you a little bit picking up that the little box that shows up. And again, it comes up in a flash, and as soon as you move, it goes away. But that gives you that same information that we had over here. All right, so we have a couple of dimensions on our drawing. Let's see, you don't like the direction of that arrow? Yeah, that didn't help. That made it worse. I was going to find a better spot for it, but we'll reposition that one. All right, so let's go ahead and save this. This is going to be my chapter 4. All right, so I'm keeping my fingers crossed. We hit next. It picked up the drawing number, so that's a good sign. And then, we did 329. All right, so let's do 329. We'll finish out the drawings, and then I will pick up with the rest of chapter 3. All right, so in inches. All right, so this particular part, I'll look at it again. Kind of lends itself to the contours and regions. I can generate a lot of that geometry in the first section, and then go back and pick contours and regions to generate the rest of the geometry. So 1.3, 2.75, the notches through. So let's give it a shot. See what was, oh yeah, that was on the depth, so that would be an all the way through as well. Front plane sketch, and our diameter is 1.38. Again, whenever you see those 2 place decimals, you should be asking yourself, should I carry it to 3, 4, 5? You know, it's even though we don't have the precision, you know, at the 2 decimal places, when I take this into the drawing, if I decide it's 1.38, I can always let it round. All right, and then the rectangular square in the center will give me 0.5 by 0.5. Nope, 0.5 by 0.31. All right, so from the center out. So basically, no, I went the wrong way. So if I leave that one, that would be 0.62. And if we're going to take these out, 0.625. Take these out to the next decimal. All right, so 0.5 on the height. Yeah, 0.25, 0.25, 0.31. All right, and since that notch is going to be part of the build out, I'm going to go ahead and continue to the intersections. All right, and if I build that out, let's see, that becomes part of that cut, and that becomes part of that cut. So one more. Yeah, we'll just go midpoints. Okay. So with that geometry, I should be able to extrude the first one, 1.3. And again, I'll point this out. I'm making this a little more complicated to use some of the features that we wouldn't normally get to use. So 1.125 is taking it out to the 3 decimals, and we're going to start with the outside contour. I'm going to share that sketch by picking on the sketch, going back into the extrude boss base. My sketch is now back here, and the contour that I want is here. And I need to pick up that sketch and say, well, let's start at this surface. All right, and then its depth. No, I didn't work that one out too well. 1.25 would be 2.5, and the 2.75 would leave that as 1/4 of an inch. So there's got to be a better way to do the math, but I don't want to spend that much time doing it, so we'll go with the math. 0.25, selecting the contours, is that segment. On the end of that one, actually we'll go back into sketch, extrude boss base, contours and regions. Now is that, and that. Pick all of that up to the surface, and actually let's do a vertex just to be different. Vertex is a different selection. It's going to be to that endpoint, and then this becomes 1.125. So I think I could have made that more complicated. Let's see, the overall was 2.75. Let's see if my math played out. 2.5. All right, so maybe that was 1/2 an inch. If not, it is now. All right, set the rebuild. It stretches it out. That looks a little bit better. But again, it's the way you see the geometry. We built this in separates. In previous videos, I've made cuts. I've gone different directions. There is no right and wrong way to get these geometries in. As long as at the end of the day my geometry matches yours, I really don't care how you got there. All right, and this one comes in to our sheet. And, oh yeah, since I've committed these to 2018, guess what I'm going to be doing for the rest of the chapter? 2018. All right, so we did the view palette. Otherwise, we would do model view, bring in 329, hit the little blue arrow, create the multiple views. Even if I don't need all of my views, I can turn them on. So that's kind of the be careful with these because, well, we can go and everything that's highlighted, oh, give me a couple of those too, and whatever position it's in. I think I have enough. All right, and because the center mark came in, it sees that cylinder. We'll go into the properties, and we'll pick up the 1/2, and okay. So this did not pick up the title. It was on the description. And so we have both of those at chapter 4. We'll kind of clean these up. I decide that, I really like those views. They display something, but realistically, I need to user define. And I thought I said all of those globally. Maybe not. 1/2, about 1/4. Well, one of them should be shrinking somewhere. All right, so make sure use parent scale. And I lost the front plane. All of them are moving around that one, so that's a good sign. Oh, and the front plane or the front view is set to custom scale. We go to sheet scale. That looks a little bit better. All right, so only these are still independent. All right, the isometric, trimetric, dimetric, and current model view. So way too fun. Dimension, don't like that it's a radius. We're going to go back to its liters, change it to diameter. See, kind of surprised that didn't get a center mark, so we want to set it for a center mark. Oh, annotation, center mark, pick the circle. And then the advantage of the center mark is that I'm going to be able to go to those points. And then since we set the whole drawing sheet to metric, we're jumping back to metric. All right, so when we're mixing the units, we may have we may just gather up all of our inch drawings and all of our metric drawings and make separate, or we can go back and turn those dual dimensions on. So kind of making a mess out of that one. Probably would like to stagger. Okay, so these do have to be readable, and we do need to be concerned with how they look in relation to the extension lines items fitting in. All right. So go through and experiment. Have fun with Chapter 4. This is by no means ANSI Y14.9. Blah, blah, blah. It's go through and learn how to use the tools and get a good sense of what they do.